Welcome to the deep dive. Today we are getting into the technical details of a piece of hardware with a name that is, well, it's a bit of a mouthful.
It is, yeah.
It's the Thor Broadcast F-2HD-1D-TVI-TXRX to HD-TVI 1080p video optical converter.
Rolls right off the tongue.
So our mission here is to figure out the strategic value of this thing. I mean, it seems really niche, but we want to understand how it bridges that gap between older analog security systems and, modern fiber optic networks.
And that context is really everything for you, the listener.
Mm-hmm.
Because while you hear all about new digital IP cameras, the sources we looked at remind us that there are just tons of these legacy analog cameras still out there.
The HDH, HDTVI, that sort of thing.
Exactly. And they're still working perfectly fine, and frankly, they're a lot cheaper to maintain. This little box is what keeps that massive investment relevant.
Okay, let's get into the core function then. What is it actually doing?
So at its heart, it's designed to take two channels of that legacy video.
Two channels, unidirectional.
Right. And it's not just some blurry old standard def signal. We're talking up to 1080p, which is the best those analog systems could do.
And maintaining that fidelity over a long distance, that's got to be the main challenge.
That's the whole game. And the quality is achieved through, well, two really crucial engineering choices. First, it uses 10-bit digital video encoding.
Which is great for color depth.
It is. But the real secret sauce, I think, is the uncompressed transmission technology.
Okay, that's the part that jumped out at me. Why uncompressed? I mean, wouldn't it be way more efficient to just compress it with H.264 or something and send that over the fiber?
That's a great question. You'd think so, right? But in a security situation, compression is your enemy. It creates two huge problems: latency delay and visual artifacts.
So the picture gets blocky and there's a lag.
Exactly. And if you're trying to track something in real time, that's a non-starter. Uncompressed means the data stream is mathematically perfect. What you see is what the camera sees instantly.
And that directly enables the range, I assume.
It's what makes it possible. This conversion lets that pristine signal travel 20 kilometers right out of the box.
20 kilometers, just to put that in perspective, that's about 12 miles.
Yeah, think about sending a perfect HD video from one end of a huge university campus to the other. And you can get options to push that all the way up to 80 kilometers.
That is just incredible. And I noticed it's not just the video either. It has that optional reverse data channel.
The RS-485, yeah.
And that's for controlling the cameras, right?
Yeah.
The pan, tilt, and zoom.
You got it.
Yeah.
Because you don't just want to watch the feed from 20 kilometers away, you need to be able to control the camera. That reverse channel is critical.
So you have this really sophisticated setup, 10-bit encoding, uncompressed, 20-kilometer range. You'd expect it to be a nightmare to install.
You would.
But the sources kept highlighting plug-and-play convenience. How does that work?
It's all about the design philosophy. The components are such high quality that the system is basically self-regulating. You just plug it in. There are no optical or electronic adjustments to make.
So no need for a specialized fiber optic technician.
Not for the setup,
Right.
no. And you can tell right away if it's working. It has these little LED indicators for things like loss of signal, power, and video.
A quick visual check.
Yep. And it's flexible. You can have it sitting on a desk or just slide it into a standard server rack.
Which brings us back around to the economics. I saw the power consumption is tiny, under 5 watts.
It's very efficient. But the real value isn't the power bill. The real value is the return on investment. This unit costs around $700.
Okay.
Think about what it would cost to rip out and replace every single analog camera across an entire industrial complex. We're talking tens, maybe hundreds of thousands of dollars saved.
Right. It's an upgrade, not a replacement.
That's the key.
So to sum it up, we've seen how this one converter gives you this uncompressed, high-quality, long-distance solution. It leverages all that existing infrastructure.
And that is the big picture, isn't it? The ability to just upgrade your transmission link to keep your cameras, but run them over fiber at full 1080p, that completely changes the math for these big organizations. It lets them extend the life of their equipment, which it raises a pretty interesting question.
So here's a final thought for you to mull over. Given that 20-kilometer standard range with the potential for 80 kilometers and how easily it works with all these older camera standards, how many massive institutions, from industrial plants to citywide surveillance grids, are quietly relying on this exact blend of old reliable tech and new high-speed fiber to keep their security effective without breaking the bank?